What's up, Washingtonians? It's Miss Sorensen here with Advanced Trigonometry, our next unit. And as the title of our unit implies, this is getting a bit harder. However, you can see here that we only have 8 topics, and so the unit is a bit shorter. What I'd like you to do right now is I want you to make a sheet in your notebook. This is something that you're going to be able to use on your final and on the test here. You are allowed to have this sheet right here on your final and on your test. This is kind of like a cheat sheet. You should know these by heart, so not a huge deal. You should know these by heart as well. We're going to learn this unit, and then I think these two are brand new as well for you. All right, so these are the reciprocals. We know cotangent's the reciprocal of tan, cosecant's the reciprocal of sine, secant's the reciprocal of cosine. We know that tangent is sine over cosine and cotangent is cosine over sine. All right, get those down, please. Last thing I want to say before we move into this unit is that number 8 here, proving trig identities, is by far the hardest topic, I think, in all of pre-calc. If you give yourself a little patience and say, all right, I know these problems are going to take a while and I may not get it right away, I think you'll do just fine. All right, let's get started with the double angle formula. So here's the double angle formula right here. It basically says sine of 2 theta, remember theta stands for an angle, is actually just equal to 2 times sine theta times cosine theta. And that's really interesting, and I want to verify that the formula actually works. So is this formula right here written in the same format as this? Well, the answer is yeah, right? It's written as sine as 2 times theta, where my theta is going to be 30. And I want to verify that this actually works. And we're going to do this quite a bit in this unit where we prove that one thing on the left is equal to the thing on the right. This is kind of called proving something to be true. And traditionally what we do is we manipulate this thing all the way down until we get an answer. And so let's do that right now. So sine of 2 times 30 is what? Yeah, it's sine of 60. Okay. And what is sine of 60? Well, we go over to our unit circle. I find 60 degrees. Remember, it's computer science, where sine is the second coordinate. So we know it's root 3 over 2. And notice how I'm writing straight down. It's almost like I'm simplifying down. And I'm going to rewrite this. I'm going to try to get the equals to be all perfectly lined up. Just like that. So I've got sine of 60 here. All right, so you can see I've got my equal sign, equal sign, equal sign. Just straight lined up right like that. Okay, so now I'm basically saying, hey, I really want the right side to be root 3 over 2. Well, we have to apply the formula being 2 sine theta cosine theta. So I have to write 2 sine, and then what's my theta in this situation? Well, remember I said it was 2 theta, where my theta is 30. So this is going to be 2 sine 30, and then cosine 30. So all I've done right here is identified my theta, and I've just plugged into my formula. Okay, now it's time to go ahead and use our unit circle, and I need to find sine of 30. Well, sine of 30 is 1/2. So I'm going to rewrite the 2. Instead of writing sine of 30, I'm going to write 1/2. And then let's find cosine of 30. Well, cosine of 30 is going to be the first coordinate, or root 3 over 2. Okay, well, what happens with a 2 and a 1/2? Yeah, of course, they cancel. And so we're left with just root 3 over 2. And so have we verified that this is true? Yes, we have. I like to put a check. In fact, some people like to say QED, which is a Latin word of saying, I have proven that which I have sought out to prove. You don't have to do that, but I kind of feel fancy doing it sometimes. All right, forget about degrees. Let's go ahead and let's do one with radians. All right, my first thing I'm going to do is just work this equation all the way straight down. So this is going to give me sine, and I'm going to multiply my 2 times pi over 4. Remember, that 2 is just 2 over 1. Multiplying across the numerators, I get 2 pi. Back this up a little bit. This is sine of 2 times pi is 2 pi. And then 1 times 4 is obviously 4. Okay, so all I've done right here is multiply those fractions right there. All right, now I can go ahead and reduce 2 pi over 4, obviously dividing by 2 by the numerator and the denominator. And that's just going to give me sine of pi over 2. Well, what is sine of pi over 2? Let's go ahead and look at my pi over 2, and my sine is going to be my second coordinate, which is 1. So now I want to use the equation on the right side, and I'm hoping that I get a 1 at the very end. So let's do this. What's my theta in this case? Well, remember, this is 2 times theta, theta being pi over 4. So this equation is going to be 2 sine of pi over 4, and then cosine pi over 4. All right, now we need to go back to our unit circle, and we need to find our pi over 4, which is right here. And both our sine and our cosine are root 2 over 2. So I'm going to have 2 times root 2 over 2 times root 2 over 2. Okay, now I have to go ahead and multiply, and I can see right away that we've got something that cancels out. So I'm just going to go ahead and cancel that 2 and that 2. And what we end up getting is, in the numerator here, square root of 2 times the square root of 2 is the square root of 4. Right? What's the square root of 4? It's simply 2. Okay, so what I'm saying out loud is square root of 2 times the square root of 2 is equal to square root of 4, which is equal to 2. All right, now let's go ahead and multiply our denominators. Well, that's just going to be 1 times 1 times 2, which is 2. And what is 2 divided by 2? It is 1. So does this formula work? It does. We haven't proven it for every single situation. We've just proven it for 2, but I think I've given you a pretty good case that this formula works. All right, let's move on to the next problem. I'd encourage you to stop this video and try to do this one on your own, and then kind of fast forward to where I've got the answer and make sure that yours matches mine. All right, so presumably you have done this problem on your own, and your answer should look like the following. We've got sine. This ends up being 10 pi over 6. And then that becomes sine of 5 pi over 3, because I've divided both by 2. And then I do sine of 5 pi over 3, and I get a negative root 3 over 2. Now on the right side, I've identified my theta as this. And so I've got 2 sine of 5 pi over 6 times cosine of 5 pi over 6. Drop down the 2. We find that our sine of 5 pi over 6 is 1/2. And then we find that cosine of 5 pi over 6 is negative root 3 over 2. Obviously, 2 times 1/2 is canceling out here, and that basically becomes a 1, or it just disappears, and we get negative root 3 over 2. And we're kind of already there, but we want to drop that down one more time. No big deal, rewriting it a second time. And we get that that does work. All right, I want to do a little bit of review before we go on to something that's a bit harder on this particular topic. I want to talk about drawing reference angles. If you're in your first quadrant, and I'm drawing a reference angle, remember you're starting here, and then your reference angle would be this one right here. So if I asked you to draw a triangle here, what would that triangle look like? The triangle would look something like that in the first quadrant. In the second quadrant, our reference angle is always to the x-axis, so our reference angle is going to be this one right here. All right, now in the third quadrant, you can go ahead and guess that, but we know that it's going to be in reference to the x-axis, so when we draw a triangle, it's going to be right there. Same thing here. We would draw our triangle with reference to the x-axis. There's our theta right there. Okay, and this is, of course, the fourth quadrant. Okay, next thing I want to review is Pythagorean theorem. Remember, we're always labeling our sides A, B, and C, where A is a leg, meaning one of the shorter sides. B is a leg, again, one of the shorter sides. And then C is across from the 90. Sometimes I like to say let A be your shortest side, B be your medium side, and let C be your hypotenuse. It really doesn't matter how you label A and B, as long as you get your C correct, which has to be across from the 90. So remember, we've got A squared plus B squared equals C squared. Let's do an example where I have, let's say, 5 and 7 here. So that's going to give me 5 squared plus 7 squared equals C squared. Okay, well, what's 5 squared? Obviously, that's 25. And what's 7 squared? That's 49. So you've got 25 plus 49 equals C squared. So then you have to add up 25 and 49, and you get 74. And of course, your last step is to square root both sides. The square root undoes the squared, and you're just left with simply C, or your hypotenuse is the square root of 74. If you can reduce the square root of 74, you should. I'm not sure that one does reduce. Okay, next thing I want to do here is I want to try doing the same thing, but I want to do it with giving you the hypotenuse. So let's say that this one is 12, and let's say that this one is 5. Now you can see here that we actually have our B that's missing, or you could say A, doesn't matter, but the point is that you have your hypotenuse, and that's what makes it different from the one above. So here you're going to have A squared plus B squared equals C squared, but notice you're plugging in for your C squared, so you've got 5 squared plus B squared equals 144, or 12 squared, right? So I've basically plugged in for A and plugged in for C. That's going to give me a 25 plus B squared equals 144. Subtract 25 from both sides. 25's cancel. And 144 minus 25 is 119. You get B squared equals 119. Square root both sides, and I'm left with B equals the square root of 119. Okay, so I can go ahead and kind of erase that B, and that's the square root of 119. And I don't think that one reduces either. Now for this topic, I really want you to make sure you know your Pythagorean triples. That's going to save you from doing the Pythagorean theorem when you really don't have to. Now notice that my A is my short side, my B is my medium, and my C is my long. It's really most important that you realize the red is the hypotenuse. So Pythagorean triple is just basically saying, hey, there are a bunch of right triangles where we don't have decimals or square roots as sides. So for example, there's a 3, 4, 5 right triangle. You should have that one memorized. So if you know there's a 3 and a 4 for legs, you know the hypotenuse is 5. And there's also a 5, 12, and 13. There is also a 7, 24, 25, 6, 8, 10, etc. What are the most important ones to memorize? Well, I think the 3, 4, 5 and the 5, 12, 13. Okay, and you might say, hey, Ms. Sorensen, how come we got a square root on this one? Isn't that a Pythagorean triple? And it's not, because look, it's the hypotenuse that has to be 13. Okay, and that's not the case in this situation. So if you have these two memorized, you can actually just use similar triangles to find the other one. So for example, if we take 3, 4, and 5 and we multiply it by 2, we get our 6, 8, 10. Okay, same thing here. If I take my 5, 12, 13 and I multiply it by 2, I get my 10, 24, 26, which is another Pythagorean triple. Again, I don't really need you to memorize all of these, but I can tell you that these two are the ones that come up the most. All right, my last thing to review here is all students take calculus. Remember, we write this just like we write Lake Chelan, right? How we write Lake Chelan as a C. So we start over here and write all students take calculus. What does that really mean? That's telling us which values are positive and which values are negative. So for example, on this first one here, we've got that sine is positive, cosine is positive, and tangent is positive. Here, however, on the second quadrant, sine is the only one that's positive. And that's because of the S right here. Well, it's not because of it, but it helps us remember it. Here, which one's positive? Just tangent. And here, which one's positive? Just cosine. So we like to use that really to check our work. All right. All right, we've got a few more problems here, and really this is the meat of it. I know this is becoming a slightly long video, but that's okay. We've got to find the cosine of theta. Now, notice here that we're given that we've got sine of theta is this, and we're given a restriction on what theta is, what our domain is. So we need to go ahead and we need to make our little quadrant chart here. And what is 3 pi over 2 and 2 pi? Well, just as a reminder, we've got a 0 to 2 pi. We've got a pi over 2, a pi, and a 3 pi over 2. This is basically 0, a half, 1, 1.5, and 2. Okay, that's how I memorize it. All right, so where are we going to be? We are going to be in 3 pi over 2 to 2 pi, which is the fourth quadrant. All right, so we're going to be over here. Let me redo that. Okay, so now where's our theta? It's right here. And we're basically saying, okay, we know that sine is opposite over hypotenuse, so this is going to be my opposite, and this is going to be my hypotenuse. So compared to the theta, my opposite is going to be 12, and my hypotenuse is going to be 13. And I just encourage you not to deal with the negative until you think about what's right, left, up, and down. Well, here we're moving right, so that one's going to be positive. Here we're moving down, so that 12 is going to be negative. And this right here, this 13, that hypotenuse is always going to be positive. It's just that distance there of that hypotenuse. Okay, now, what did I just teach you about having a 13 as your hypotenuse? Well, you just learned that that's a Pythagorean triple. So what is this side right here? If you said 5, you are correct. And if you're not sure why, go back on the video and see that 5, 12, 13 is a Pythagorean triple. All right, so now we need to find cosine of theta. So cosine of theta is going to be adjacent over hypotenuse. Well, my adjacent in this situation, if you want to label your sides, you can, but we've got adjacent, opposite, and hypotenuse. So getting cosine of theta is going to be a over h, or in this case, 5 over 13. Okay, what's cotangent? Cotangent is adjacent over opposite, right? It's the reciprocal of tangent. So my adjacent over opposite is just going to be 5 over negative 12, and it doesn't matter where we put the negative. So we could put it with the 12 or the 5, doesn't matter at all. Now sine of 2 theta is really going to be using this formula right here. This is where this kind of comes into new content. We know that sine of 2 theta is going to be this right here. So this is going to be equal to 2 sine theta times cosine theta. Okay, well, let's plug in for that. That's going to be 2. What's my sine of theta? Well, that's right here. It's given to us as negative 12 over 13. And what is my cosine of theta? My cosine of theta is listed right here as 5 over 13. Now, of course, you can rewrite that 2 in front as 2 over 1 if you'd like. We're going to multiply across the numerators, and I get 2 times negative 12 times 5 is negative 120, divided by my denominators, which is 1 times 13 times 13, is 169. And that's our answer for sine 2 theta. And you might be saying, whoa, that's a crazy answer. And in the next video, I'm going to show you how to check that answer and prove to you that it's correct. All right, next one here, sine of 2 theta. I'm just kind of skipping the other 2 steps, but really first we need to make sure that we can draw our triangle, find sine theta and cosine theta, and then we can plug into the formula. All right, notice here that we're between pi over 2 and pi, which to me indicates that we are in the second quadrant, right? That's pi over 2, and this is pi. So drawing that triangle, we've got something like this. And remember, cotangent is going to be your adjacent over opposite because it's the reciprocal of tan. So if my theta is here, my adjacent is going to be the 4 right here, and my opposite is going to be 3. Okay, now dealing with our positives and negatives, we're going to be going left and then up. So my negative goes on the left. All right, now, what is my hypotenuse here? Well, what type of triangle is this? This is a 3, 4, 5 triangle. So this here is going to be a 5. Okay. Now, we have to go ahead and find sine theta and cosine theta. And you're saying, why do I have to do that? Well, that's in our formula right here. I think it's nice to do that work up front and then just plain plug into that. So my sine theta is opposite over hypotenuse. And let's go ahead and label all 3 sides. This is my opposite, my hypotenuse, and my adjacent. So sine theta is going to be opposite over hypotenuse, or 3 over 5. Cosine is adjacent over hypotenuse, or negative 4 over 5. So now getting this answer, we have sine of 2 theta is equal to 2 sine theta cosine theta. So sine of 2 theta is equal to 2. I'm going to bring back my answers for these two, and my sine is 3/5, and my cosine is negative 4/5. Okay, and then I can rewrite this 2 as 2 over 1, multiply across. 2 times 3 times negative 4 is a negative 24, and then 1 times 5 is obviously 25. And this is our answer. All right, so this is our last problem here. So we've got sine of 2 theta, and we are between pi and 3 pi over 2. So that tells me that we are in our third quadrant. Why do I know that? Well, this is my pi, and this is my 3 pi over 2. Tangent is opposite over adjacent. So my opposite goes here, the 8, because this is opposite. And then my adjacent is going to be here. Now, is 8, 5, is that a Pythagorean triple? No, it is not. So you have to do the Pythagorean theorem. And after doing the Pythagorean theorem, we get that this is the square root of 89. You're welcome to pause the video and prove that, but you need to be able to do Pythagorean theorem on these problems. All right, what's my sine theta? My sine theta is opposite over hypotenuse, or negative 8 over the square root of 89. I encourage you not to rationalize until the very end of the problem because things might cancel out. Cosine theta is adjacent over hypotenuse, which is a negative 5 over root 89 in this case. So let's go ahead and solve this. We've got sine of 2 theta is going to be equal to 2 sine theta cosine theta. So sine of 2 theta, let's plug in, we get 2 times negative 8 over root 89 times negative 5 over square root of 89. Okay, put this 2 over 1, and we get the sine of 2 theta is, let's multiply my numerators, 2 times negative 8 times negative 5 is an 80, and then 1 times the square root of 89 times the square root of 89. Well, multiplying these two things cancels out the square root, and we're just left with 89, and that is our answer. All right, thanks for watching, folks. Hope you're having a fantastic day.